Hey everybody, welcome to lesson 2 of Java. It's mostly just for friends who are asking about how to learn how to code. Today is going to be a pretty hefty lesson. We're going to go over quite a bit today, so I highly recommend that you guys take notes of some sort. I apologize ahead of time for the background noise. I'm actually home in Portland, Oregon for a wedding, so I'll be doing this lesson with a bit of ambient noise. Anyways, let's get started. So we went over a bunch of stuff last time. Mainly, I'm going to erase this. Mainly just over variables and variable types. So we went over ints. We said that variables needed to have a shape or a type. Int is a type in this case, a name, which is index, and then you can put things into the variable using the assignment operator, which is a single equal sign. We also went over a second type called a float, which needs to end with a f and uses an equal sign. These two things are different types, so trying to put one into another leads to kind of tricky situations that you have to be aware of. The last thing I forgot to go over is actually how to create comments in Java. In Java, you need to put 2 forward slashes, and you can type whatever you want here. This is mainly for developers so that they can remember what they were writing previously. So you could say something like, so that later on you can remember what you were doing. Um, Another way of writing comments is /star, which needs to be followed by another star /, and anything in here between these two counts as a comment. You can actually consider it a scope of a comment, although that's not really the naming convention or terminology that's used. But yeah, this is just for larger comment blocks. You could see that NetBeans uses it here to talk about command line arguments. Anyways, let's go on to today's lesson. So today's lesson is where we're talking about conditionals, and this is where a lot of the cool stuff in coding comes from. Conditionals are basically just gates. You can think of them as basically checks in logic that change how code flows in your program. The most common conditional is called an if statement. So you just say if, open parentheses, close parentheses, followed by an open curly brace, and ended by a close curly brace. Now, you put your condition in here. In most situations, the equivalency operator is 2 equal signs. Okay? What this says, if the thing on the left side is equivalent to the thing on the right side, then it resolves to true. Otherwise, it resolves to false. I'll show you an example. So, I have a variable here called k, and it's set to 0. If k, whatever's inside of it, is currently equal to 0, then whatever is inside this open curly brace to this closed curly brace executes. Otherwise, if this fails, this if statement, whatever's in here, doesn't happen. So when I run this program, k is set to 0. If k is equal to 0, then it's going to run this line. And if I run the program, you will see the condition is satisfied. So what happens if k is not equal to 0? In this case, k is 4. If I run it, this line does not get fired, and you see nothing. All right. One thing to note is that if you have code that follows before or after the if statement, it will still run. The if conditional only applies to things inside the scope of the if. And once again, scope in this case is this open curly brace to this closed curly brace. So if I have stuff after, or before, running the code, then k is set to 4. It checks to see if k is 4, otherwise it skips, which it does, and then this will always run. So you notice that because the condition was not satisfied, this did not fire, but what's happened before and what happened after did run. So it's important to note the scope of your conditions and conditionals and what they're trying to check. What you can do in addition is what's called an else. So following the if and immediately after this curly brace, it can be in the next line, you say the keyword else. The else also needs to have an open curly brace and a closed curly brace. It's not a hard and fast rule, but it's just for convention's sake. It's easier to read, so always do it. So if this condition fails, it now runs whatever's in here. If this is true, then do this. Otherwise, do this. That's what the else statement says. See, when I run the program, running the code, condition failed, this will always run. So if, else, and then what follows. So why is this important? Well, you could think of it in terms of, like, let's say your bank account. You want to make a withdrawal. So you could say something like, say that there's like a bunch of code in between here. This condition checks to make sure that the balance is what it should be, and if it is, then it runs. It's been validated, otherwise there's been an error. There's a couple of other, well, let's see what happens. So amount validated because this variable didn't change. There's other equivalency checks that you can make here. So equals equals means that the left and right side have to be exactly equivalent to one another. Exclamation mark equals means not equal. So if the left side and the right side are not equivalent to one another, then it resolves to true. It's basically like flipping these two blocks. So in this case, what will happen? This top block will not fire because current balance is equal to 40,000. So the else statement will fire. See, error verifying balance. So this is not equal. Exclamation mark equal sign is not equal. Then you have less than is this. So if current balance is less than 40,000, then this will run. Otherwise, the else statement fires. Once again, doesn't work. Then you have greater than. If current balance is greater than 40,000, then this will run, which once again is not true. And then you have greater than or equal to, which is this combination of characters. It does, because current balance is equal to 40,000, so greater than or equal validates to true, or resolves to true, and this fires. Likewise, less than or equal to is just a less than symbol with an equal following it. So now we've done These are all the different kinds of basic conditional checks. There's a couple of other ones, but for the time being, these are the ones that we're going to concern ourselves with. Now, the important thing to note is that these really only work with primitive types. I've added a link here in the Hangout under the Showcase app. Let me show you guys. Primitive data types. It shows what the basic data types are and how you can check for equivalency. So I would give that a read. If you guys can't see that link, just let me know and then I'll email it to everyone directly. So the important thing to note is that these work with primitive data types, and primitive data types are the most basic variable types. They are not objects. So this includes integers, floats, chars, which are individual characters, and booleans. Booleans are variables that can only be either true or false. So the only thing that they can hold is either true or false. When it comes to objects, objects are created instances of classes. It's a very complicated combination of words. I'll explain what that is in another lesson. But anything that's a collection or a grouping of primitive types is can be thought of as an object. It's much more complicated than that, but just for the time being, we'll just think of it that way. Um, so, for example, the variable that I showed you guys before, a string, is actually a collection of the primitive type char, or characters. It's a group of characters placed together, which turns out to look like words that we're used to, like this. Like this is a string. Each individual character put together and held in one variable. It's a string. So I can do something like this. So now here's something interesting. String, this type, is a class. There's a class called string that Java gives you, and it describes all the things necessary to describe a string and all of the methods that you can use to do lots of things with strings. Um, so in order to check whether strings are equivalent, you can't use these normal equivalency checks. Once again, this is because string is an object. Strings are objects. So you have to use special methods in order to check whether or not two strings are equivalent to one another. So to prove this, I'll run a quick example. So you'll see that string var and other string hold the exact same string literal. This won't work because when you have two objects and you use the double equal sign, what it's checking for isn't whether the stuff inside of them is the same. It's actually checking to see if the whole location in your garden, going back to the analogy that I brought during the last lesson, this is checking to see if the whole location is the exact same. So if the whole for string var and the whole for other string are the exact same thing, and you'll see that when you run this, oh, what the? I guess they are the same. That's kind of weird. This shouldn't have worked. I don't know why this is working. I guess they must have changed. They must have changed it. This shouldn't have worked. But anyways, you're supposed to use dot equals. I guess they're string literal, so this will work. There you go. Well, you're supposed to use dot equals. I messed this up because these are string literals. It's different. It treats them differently. But if I did, yeah, so instead of holding a literal string, I now told it to hold, I created a new object which is of type string, and I put this is a string in it. So, man, this is actually a lot more complicated than I was hoping to talk about. But just trust me when I say, I'll get to this at another lesson, but just trust me when I say that if you want to compare two strings, you have to use dot equals to compare them. So you take the variable name of the string, you do dot type equals, open parentheses, and then you write the string that you want to check for inside of the variable. And if this is true, if what's in string var is equivalent to this string, then it will run. Otherwise, like normal, the else statement will run. So if you want to check what's inside, make sure you use dot equals. Now, the other conditional type, well, the other thing that I want to show you guys is else if. So what this does is first it tries to complete the first condition here. And then if that fails, it then checks this condition. And if this condition is true, then it runs this block. So you can actually string a bunch of else ifs together over and over and over and over again. So let's walk through this line by line. If whatever's in string var currently is equal to this is AMA string, it will print out they are the same. Otherwise, if whatever's in string var is currently equal to this is a string, it will print out second check is the same. Otherwise, if what's inside string var is equal to hello world, it'll print out hello world. Otherwise, in any other situation, it'll print out not sure what the string value is. So if I run this, not sure what the string value is. It's because this here is missing an exclamation mark, so they aren't equivalent. If I put this here, second check is the same. Got it? All right. Now we're going to move to switch statements. And switch statements are a cleaner way. Oh, it's all preference, but it's just useful to know. Switch statements are kind of a condensed, cleaner way of doing multiple else if statements chained together. They usually are used for primitive types, typically integers, when you want to handle different cases of what the integer could be. So it looks something like this. So I have a variable called k. And when I switch on k, it says whatever's following this block is going to be checking for various values of what k could be. So if k equals 0, case 0 will fire. Whatever's in here will fire. Otherwise, if k is equal to 1, case 1 will fire whatever's in here. In any other case, if none of these previous cases are satisfied, in other words, if k isn't equal to 0 or 1, whatever's in default will run. It's 0. If I change it, 1. If I change it again, unknown value. So the important thing to note is that you have to switch on a specific variable, and then you have to write these case what value colon followed by whatever code you want to run, and it has to end with a break. If you don't end with this break, it will actually run into the next case. So if I got rid of the break, what happened is that int k equals 0, switch k. K is currently equal to 0, which means it'll run case 0. So it prints this line. Because it didn't find a break, the line of code kept going, which means it spilled into the next case, which is here. So if you don't put the break, it'll just keep spilling into the next case below. So it found case 1, it ran this code, and then it found a break, so it completed and exited the switch statement. Okay, so this is really useful for when you have like, let's say like more than 5 different cases you want to handle. And this is the equivalent. You could have also written it as but it's just a different way of doing this exact same thing. If k equals 0, run here. If k equals 1, run here. Otherwise, we'll run whatever's inside this else statement. All right, cool. Now, let's talk about nested conditionals. I have an if statement here. You can actually write another if statement inside of this if statement. What's going to happen? K is currently 0. This condition is true. K is 0. So then it jumps inside of the block, the scope of this condition. It runs to here. K is still 0. I haven't changed it. It's because K is still 0. This resolves to false. This is never run. And then it goes here and prints out it's 0. So because of this set of code, this condition will never fire. The only way to make it fire is if I did this. So K was 0 at this time, which made this condition be true. K now switches to 1, which makes this condition be true. It prints this out and then prints this out. All right. Now, if I did this, this block of code will never even run because this initial condition failed. All right. This is nested if statements. Is putting one if inside of another. Okay. You can also put else if or an else here. Same rules apply. And you can keep nesting them inside one another, one another, one another. This is useful for when you want to check multiple conditions if they're true. You can also chain multiple if statements together with an and or an or. Oh, let's see what this looks like. So this is saying if k is equal to 0 and it's equal to 1, then run whatever in this block. Of course, it's not possible, so nothing happens. This never prints out. This is a pipe, two pipes together. Usually on your keyboard, it's the symbol above the return key and below the delete key. You hold shift and you hit the backslash button twice. So this is if k is equal to 0 or it's equal to 1, then it resolves to true. So, yep, that ran. So and or. There's actually a bunch of others, but for the time being, we'll just worry about and, which is two ampersands, and or, which is two pipes. A single ampersand and a single or is something entirely different. It's a bitwise operation, which is something else we'll get into. But for the time being, just remember that if you want an and, it's two ampersands, and if you want an or, it's two pipes. Moving on. Say that I have a string and I want to pull a single character out of the string. So once again, a string is just a collection of characters. So how do I pull out an individual character? I want to figure out what the fifth character in this string is. So to do that, you use the char at method. Now, whatever number you put in here is going to pull that index of the string out and return it. So what I'm saying right now is take the variable string value, take the character at index, and I haven't put anything in here yet, and then store it into the variable called current char, which I'm now going to print. I want the fifth one, so I'm going to put 5. Now, this is actually wrong, because if you check, what we should actually get is this empty space. Or 1, 2, 3, 4. Yeah. We should get this empty space, but we got the sixth character I. Why is that? Well, because the first index is actually 0. So instead of counting 1, 2, 3, 4, 5, you count 0, 1, 2, 3. Yep. I printed out a space. If I wanted the first one, letter is T at 0. So you have to remember that when you're doing any kind of indexing, the first index is always 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. All right. So why is this interesting? Because you can do something like this. With characters, to check for equivalency, you do equals equals because chars are primitive types. They're not objects, so you don't have to do the dot equals thing. You use regular equals equals sign. And then if you want to compare it against an individual character, you use a single quote. This. So I'm looking to see if current char currently holds a single capital T. It's case sensitive, so lowercase t and capital T are going to be two different things. So if current char is a capital T, then run whatever is in here. And it is, so it runs. If I change the current char at, let's say I want the H. Okay, I want this. So I need to change it from 0 to 1. Fly on me. and nothing happens. See, this doesn't print. It's because current char is currently holding an H, not a capital T. So what if I wanted to run through the entire string? Well, I could just do this. So, well, I have to get rid of this, but you guys get the idea. This is really, really painful. Um, I check 1, then I check to see if index 1 is equal to capital T, and then I check 2, and I check if index 2 is equal to capital T. So I'm just repeating this line, copying and pasting over and over. This is terrible. So the way that we actually do this in a very efficient and easier to read manner is using a loop. So now we're going to be moving from conditions over to loops. So here's what a loop looks like. We're going to start, there's 3 different kinds. We're going to start with a while loop. So just like in the if statement, you have a condition, and then you have a block. So what this says is while this condition is true, keep repeating whatever's inside the block. The really tricky part about this is you have to make sure that at some point this condition resolves to false. If this condition never resolves to false, this loop will go on infinitely forever, which is a very common bug called an infinite loop. This is an infinite loop. Current char is currently the first element of the string, which is a capital T. So while current char is equal to capital T, this loop will run. Because current char never gets changed, this loop will go on forever, and your computer will eventually run out of resources and crash. So this is really bad. The only way to make this stop is what happens now. Current char is equal to capital T, while current char is equal to capital T. This evaluates to true, and then it shifts the value of current char to W. When the block resolves, it then goes back to check if the condition is true, which it now no longer is true, and it then terminates the loop and jumps out. So you'll see here that I'm in the loop. This will only print out 1 time. See? Because I changed the condition to resolve to false after the first time through, the first iteration through this loop. I could have done something like this. Let's say I want to make this run 10 times. You can do something like this. Happens. I is currently 0, which passes this condition. I is less than 10. Yep. So then I print this out, and then I take I add 1 to it, and I put it into I. So I'm basically just adding 1 to I. So it goes from 0 to 1, 2, 3, 4, 5, 6, 7, 8, 9. And then on the 10th time, it'll terminate. This block will never run. So you'll see this print out 10 times, which it does. Now, if I did less than or equal to, it'll run an 11th time, okay? Because I started it at 0. 0 is the first time, 1 is the second time, 2 is the third time, 3, so on and so forth. When it hits 10, it's going to run for an 11th time. There's actually a quick way of incrementing I by 1, and that's actually the plus plus operator. So what this says is just take I, add 1 to it, and then set that value to I. It's equivalent to doing these two things are the same thing. There's a slight nuance between them, but for the most part, they're the same thing. It just adds 1 to I. The result's the same. So the thing about while loops, though, is that they are not guaranteed to run at least one time. If this condition is false initially, then this loop will never run. So I is 100, I is not less than 10, which means that this loop will never run and you won't see anything. So if you want the loop to run at least one time, you use what's called a do while, which looks like this. So what this says is do this while this condition is true. So unlike the while loop, this will run at least one time. See? It runs the code and then it checks after it's run whether the condition is true. If the condition is true, it does it again. Otherwise, it jumps out. So you use a while loop if you don't care if it runs at least one time, and you use a do while if you want it to run at least once. That's the difference. So now let's do something interesting. There's a lot of things going on here. I'll break it down line by line. So I set current char to hold the first value, right? And then I created a variable called I that's an integer, all right? I then use a do while loop. I print out the current character, which is the first, on the first run is the first letter. It's capital T. Then I update current char. Oh, actually, this is wrong. I need to do it this way. Then I update the index, and I set current char to what the new index is, right? So it goes first run, this is holding capital T, I is 0, it prints out capital T, I is now 1 because it adds 1 to it. I take the character at index 1 and I put it into current char. So now it's holding this H. It then prints out the H, increments it to the index number 2, and then does it. So it keeps going. It will continue while I is less than string value.length, the length of the string. Unlike the index, this actually counts it in normal human terms, which is 1 letter, 2 letter, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So you have to remember that when charat runs, it starts from index 0. When you use length, it actually returns the full length of the string. This is really useful because this evaluation makes sure that you're never trying to pull a character outside of the length of the string. But there was an exception. Why was there an exception? If someone can email me and tell me why there's an exception in this code, you guys will get a special point, special props from me. I'm aware of the exception. I actually ran it knowing that there was a problem, but I'll leave it to you guys to figure it out. All right. So one more loop that we need to go through is the for loop. And it mixes a bunch of these things together to make everything a lot easier. But it looks kind of complicated. So here's how it works. So here's how for loops work. It runs a specific number of times. You have to give it an initial variable, a condition, and then an increment at the end. Okay? So in this case, the initial variable I'm going to give it is called I, and I'm going to set it to 0. This is our counter. Our counter is going to be called I, and it starts at 0. While I is less than, here's the initial variable I. While I is less than string value dot length, you run whatever is inside this for loop. When the for loop completes, you then run whatever's in the final section back here, which is, so first create a variable called I and it's set to 0. Then check to see if I is less than string value dot length. If it is, then you run the loop. After you're done running the loop, then you run this last part, which is incrementing I by 1. Let's walk through this. I have a string called string value. Here's what it is. Int I is initially set to 0. Is I less than the length of the string? Yes. 0 is definitely less than 16, which is how many characters there are here, right? So then I run what's in here. I take string value, I look for the character at index I, which I at its first run is 0. And then I take that character and put it into current char. Okay? So what is the character at index 0? It's capital T. I put capital T into current char, and then I print it out. Now I'm done. When I hit this curly brace, I then do whatever is in this final section over here, which is incrementing I by 1. Now I is equal to 1. Is 1 less than string value dot length? It is. I take the character at index now 1 and put it into current char and print it out. I hit the end of this block, which increments I by 1, is now 2 less than string value dot length. It is, so on and so forth. Once this condition fails, this for loop terminates. And so you see it prints out every letter. Cool? Now I can put additional conditional checks inside loops. This works in do, while, and for. So here's an example. So if in the current iteration or time through the loop, I find that current char is a lowercase I, I'm going to run whatever's this statement, which is the letter I was found at index. So because these are double quotes, this computer will actually print out these characters as it's shown here. And then I have a space, plus, and then a variable. So this tells the computer, print out these exact letters, including the space, and then print out whatever is the value held in the variable I. So this will tell me which index the letter I was found. So when I run it, you'll see it prints out THI, current char is equal to I, so it prints out the letter I was found at index 2. S space I, the letter I was found at index 5. And at index 13. Got it? So this is what makes loops and conditionals together really interesting. You can do some very, very cool stuff by having a condition and then a loop, or a loop and then a condition, conditions within loops, loops within conditions, conditions within conditions within loops. And you can also put loops within loops. what's happening. I have a loop within a loop. I have a for loop, an outer for loop, and an inner while loop. I is 0. Is I less than string value dot length? Yes. I take the character at index 0 and put it into current char, which I then print out. I then declare a new variable called k. I set it to 0. While k is less than 3, I'm going to do whatever's in here. I'm going to print out looping. And then, to make sure that this isn't an infinite loop, I increment k by 1. So this will print out 3 times. At every iteration of this outer loop, this inner loop will run 3 times. So I is 0, then this gets run 3 times. I is set to 1. I is 1, this gets run 3 times. So you'll see what's happened. T looping, looping, looping. H looping, looping, looping. I looping, looping, looping. So we have a for loop, and then inside of that is a while loop. These are called nested loops. Just like we had nested conditionals earlier, an if statement in an if statement, we have nested loops here. So that's pretty much all that I had for today's lesson. We've gone over quite a bit. We've gone over conditionals, if statements, switch statements, if then, if else, else if, and just regular if statements. We've gone over switches, equivalency, ands and ors, loops, which include for, do while, and while. There's a lot going on here, and I'm sure that there are plenty of questions. So if you guys want me to clarify anything, or if something was really confusing, please email me. I'll try to answer all the questions as possible. The homework that I'm sending out for this week is actually a little tricky. It's 2 very common interview questions that are asked by tech companies in the Bay Area to try and weed out engineers. It's going to be a little harder. Please try and start it early, and try to do it by yourself. Don't Google it. It's very easy to find the answers. Do yourself a favor. Don't Google it. Give it a shot. With the tools that I told you guys today, you guys can definitely finish both of these questions. So best of luck, and please let me know if you guys have any problems. Oh, I've also added how do I compare strings in Java. There's an explanation here, which will elaborate more on comparing objects and strings and stuff like that. Once again, if you can't see these links that I've added, let me know. All right, that's it. See you guys next time.